Welcome to 2.3 Polynomial Functions and Their Graphs. Our essential questions for today are: what information can we determine from a graph of a function, and what is a quadratic function? We're still answering those questions from last time. So, definition of a polynomial function. This looks very confusing. It's not as confusing as it looks. So let n be a non-negative integer, and let a sub n minus 1, etc. be real numbers, where a sub n is not 0. The function defined by f of x equals a sub n, x to the n minus 1, or a sub n x to the n plus a sub n minus 1 to the x n minus 1 plus etc. is called a polynomial function of degree n. So that is your degree. Your exponent is the degree. The number a sub n, the coefficient of the variable to the highest power, is the leading coefficient. So all this means is that when you have a polynomial function, if I have 2a to the third plus 6a to the second, this is the degree of my polynomial, and this is my leading coefficient because it's the highest degree. A polynomial function of degree 2 or higher have graphs that are smooth and continuous. By smooth, we mean the graph contains rounded curves and there are no sharp edges, so your parabola. And by continuous, we mean the graph has no breaks and can be drawn without lifting your pencil from a regular coordinate system. So you can draw it without lifting a pencil or moving anything. The end behavior of a graph of a function to the far right or far left is called the end behavior. So what's happening to the far left and right is your end behavior. Although the graph of a polynomial function may have intervals where it increases or decreases, the graph will eventually rise or fall without bound as it moves far left or far right. The sign of your leading coefficient, so positive or negative, and the degree of n of the polynomial function reveal its end behavior. So this chart is really important. So if your exponent, or your n, is odd, and the leading if it's odd, that means it's going to fall. It's going to do different things at the endpoints. So at one point it's falling, at one point it's rising. So if your n is odd, your exponent is odd, it's going to be doing different things at your endpoint. If your leading coefficient is positive, the graph will fall to the left and rise to the right. If your leading coefficient is negative, the graph rises from the left to the right. Rises to the left and falls to the right. If n is even, or your exponent's even, it's going to do the same thing at your endpoints. And if the leading coefficient is positive, the graph rises left to right, and if your leading coefficient is negative, it falls from left to right. So, use the leading coefficient test to determine the end behavior of the graph f of x equals x to the fourth minus 4x squared. So my degree, or n, is 4, and my leading coefficient is 1. So my degree is even, so same behavior. My leading coefficient is 1, which is a positive, so it rises from left to right. So if here's my coordinate, that means my graph has the same behavior and it rises left to right. Zeros of a polynomial function. If s is a polynomial function, then the values of x for which f of x is equal to 0 are called the zeros of f. We learned this with quadratic functions. The values of x are the roots or solutions of your polynomial function equation where f of x equals 0. Each real root of the polynomial function equation appears as an x-intercept of the graph. So find all zeros of that equation. We find zeros by setting f to 0, f of x to 0, and solving in the results. So we have to solve this equation, set it equal to 0, and solve the equation. So you have 0 equals x to the third plus 2x squared minus 4x minus 8. We're going to do this by grouping. So my first part, I can take out x squared, and I have x plus 2 left. And at the end, I can take out a negative 4, which gives me x plus 2. This means I have x minus 4, x squared minus 4, x plus 2. If we kept factoring, this is what we would have. So that means x equals 2 or negative 2. So we have zeros at x equals plus or minus 2. That means our graph will touch your axis at negative 2 and positive 2. At 2 it crosses. So the graph of f shows that each 0 is an x-intercept. The graph passes through 0, negative 2, and 0, 2. Make sure to answer the questions below and watch the next video. Next time we'll talk about the parts of multiplicity, intermediate value theorem, and turning point.